Welcome Volatility Box members to our new members only tutorial in which we're going to be building a dollar cost average calculator together. Now there's two different calculation types that we're going to be building into this calculator. The first one is the one you've probably heard referred to most often. It's what we'll call the default method, and this involves buying on the first of every single month and the last of every single month. It's a very systematic way of buying into a position, and it allows you to essentially turn that into a process. You're only looking 2 times every single month to add to your existing position. The idea here is hopefully over time, you've dollar cost averaged yourself into a better price. Now method number 2, which is one I'm a little bit more curious about, is what happens if you buy or dollar cost average only on red days. Red days means you buy at the close of any day in which our close price is less than the opening price, and I'm going to be using in this case the S&P 500 as our example, the SPY ETF. Now let me show you an example of what we're going to be building before we start writing the thing script together. Now here on my chart in the top left, you should notice some labels. The first label tells us which type of calculation are we using. If I open up the calculator, you'll notice there's 2 options for you to choose from, the default and the red day option. Now the second set of labels will give you information for the time frame chart you have loaded on. So in this case, I have the 5-year daily time frame. So it's saying that, hey, if you bought at the first and the last of every single month for the past 5 years in the S&P 500, your average entry price would be $362.10. You would have done this over 120 different DCA attempts, meaning 120 dollar cost average transactions. Your current return using this price and our current price of 449.16 is about 24%, and that's using your dollar cost average entry price over the past 5 years. Now the beauty of this calculator is you can very easily do things like, say, test what would have happened if you had red days. That allows you to recalculate all of this in less than a second. Let's say instead of the S&P 500, you want to switch to the Qs. Now we have the calculation for the Qs where we can see using our red day calculation, our entry price is right around $272 and our current price is $374, making for a pretty nice return over the 5-year period. Now we can also do things like expand this from say 5 years to maybe the max available data, which allows us to get a lot more data into the picture to see which method works better in the longer run. Here, for example, using SPY, we can see that our average entry price using the max available data, but the red day method, is 165.22 with just over 35, almost 3,600 DCA attempts. Now keep in mind this goes back a long time on the data since we've done the max available. But if we swap this out with our default method, which is a little bit more systematic, you can see we have just 733 trades, but that average entry price is pretty dang similar at 167.14. Now, like this, we looked at the index ETFs, but you can poke around other markets, specific stocks, whatever you'd like to look at in terms of understanding what is the best way to DCA into that particular symbol. Now with that out of the way, let's start writing our own code. I'm going to remove our existing indicator, and I'll click Create to start writing our own code from scratch. Now to get started, I'll give our indicator a name. I'll call mine TI_DCA calculator. We can remove all of the code that's inside, and now we can start by writing our own code. Now, since we know that we're going to give the user 2 different choices in terms of the DCA calculation, either the choice of the default calculation or the choice of the red day calculation, that naturally gives us an input variable that we can use. That input variable is what's going to facilitate really the rest of the code, because based on what the user selects, the calculation will change. So let's start by first creating that input variable. That's the simplest way to get started. I'll say input DCA method, and here we can give the 2 different choices that the user is going to have. The first choice is going to be default, and so that's going to be what I put first inside of quotes, and then the second choice is going to be red days. and I'll close this out with the curly bracket and a semicolon. Now with just this, if I click OK, we double click this, we won't be able to see the input since there's no plot variable and we're getting an error in the code. So to solve that, if I simply just said something like this to fulfill the error, we click apply, and now I double click the study, you can see the input variable we just created. It gives the user two different choices, default and red days. Now nothing will happen if you select either one of those since we've not written any portion of the code yet. But that's what we're going to do now. So I'll remove this plot data close, and now we can get back to writing our code. Now let's start first with defining this default condition first. As part of the default condition, we're saying buy either on the first bar rather of every single month or the last bar of every single month. Those are our two choices. So to help identify this, we can use the getMonth method, and I'll use January as an example to show you how we can go about doing this. So let's say January 1st. I'll move this cursor. And now let's define the first DCA period first, which is going to be the first bar of January. So I'll say def Jan 1st. And here we can say if getMonth. So we're calling the getMonth function, which is built inside of thinkorswim. And we're saying, hey, if the month is 1, meaning January, and the previous month was December, so 12, then return 1, else return 0. So this is now looking for the first bar of January. Similarly, we can create one variable, which is looking now for the last bar of January, so we can say Jan end, and this time we're checking if the current month is still 1, but this time the following month, so -1, is equal to 2, which would be February. If that is the case, then return 1, meaning true, otherwise false, which is 0. Now I'm also going to create one last variable, which is called JanDCA, which is going to return true if either one of these are true, meaning we did have a DCA date, and we need to store the closing price of that particular candle. Now, just like we did January here, we need to repeat this process for the remaining 11 months. What we're going to change is going to be each of these month values, but our format is going to be more or less the same. Let me show you February as an example, and then I'll do the remaining months for you just so we can save some time. So now let's create February here. So I'm going to change our text to February. All of these variable names will now need to say Feb instead of Jan. And make sure when you replace them, you change not only the actual names of the variables, but also where we reference them right down here. So this will be Feb 1st and Feb end. And now we need to change the actual numbers for the months here. So for the first DCA in February, we're going to check if our getMonth is equal to 2, since we're now checking if we're in February, and if the previous month was 1, meaning January. Then return true, otherwise false. For the end of February, similar idea, we're going to check if the current month is 2, but this time the following month is 3, which would be March. And just like that, we're going to repeat this process for March, April, May, all the way up through December, changing the numbers. It's a fairly simple process, but it does require you to copy paste a little bit and pay attention to some of these months. Let me go ahead and repeat the process for the following months, and I'll see you back in just a few minutes. Alright, so now I have put in all 12 months, so we have December down here, November, and this goes all the way up to the January and February that we created together. Now let's keep moving forward in our code. Now to trigger our method in which we do a DCA using the systematic approach, we need to have some sort of final variable which combines all of these DCA variables that we've created. So to do that, I'm going to create one variable which is going to say def, and I'll call this all DCA. And here, I'll simply say Jan DCA, or Feb DCA, or March DCA, or April DCA, or May DCA, or June DCA, or July DCA, or August DCA, or September DCA, or October DCA, or November DCA, or December DCA. Now the reason I combined all of these into one variable is now we have a nice clean way to reference, is the current bar a DCA candle for us using method number 1, true or not true? It's a very simple way that we can keep track of this. Now that we've done that, we open up the range of possibilities to start to do some basic calculations. So for example, let's say we wanted to calculate the average price. That's one of the parameters that we have for our requirements. To do that, we can now say something like def total DCA, actually we'll say total method 1 price. And here I can say if all DCA, then we're simply going to take close, the current close price, add it to the previous value for the method 1 price, and that's going to give us a running total of what is the total price of all of the different times that we've actually had a DCA opportunity. The all DCA variable will return true if we've had any one of these DCA dates. If that is the case, we're simply taking the close price and adding it to our total sum, which we can then divide by the total count to create our own average value. So next thing we need to do is create a total method 1 count. And here, same idea, we'll say if all DCA, meaning we have a DCA date, and actually I'm going to change this to all DCA dates just so it's a little easier to, I think, understand what we're looking for. And I'll replace that down here. Then here we're going to simply just add 1 to this count variable. So I'll say total method 1 on the previous value plus 1, else we're just going to return the value on the previous bar. So this is our counter. This is our total price. Now to get the actual average value, we just need to divide the two. So we'll say average method 1 price, and this is going to be our total method 1 price divided by our total method 1 count, and that's going to give us the actual average price. Let's test this by actually outputting this particular label. Let's see if it gives us something that we can use. So I'll just create a test label here first. So I'll just say yes for always showing this label. Inside, let's output the price unformatted, and I'll say plot this as a yellow label. Now if I click apply, we should see this old study simply get off of our chart since I've removed it. And we should now see a new label with just a price. It should not be formatted. It shouldn't look pretty, but it should be a start. Let's click apply and see what happens. And there we have it. We have a simple price inside of our DCA calculator in the label on the top left, and that's our average method 1 price. Let me switch to SPY, and let's go to our 5-year daily time frame chart, and that's giving us the price 362.09 over the past 5 years as our average entry price using the DCA method. Now, the next thing that we can do is, just like we created this method 1 price, we can also repeat the process now for our red days. So we've done method 1. As soon as we do method 2, which is our red days, we can then create a switch variable and the final labels that we need to output everything. So this is all going to be part of method 1. So let me separate that out here. I'll try and use some hashtags so it's nice and easy to see. So we'll say method 1, and then I'll paste this in so it stands out. And now let's repeat the process for method 2. Now method 2, let's say, is buy only on red days. And our method 1 here we said was buy on the first and last of every single month. So now for our red days, we need to add in some other logic, but this is going to be a lot simpler compared to our month logic since we don't really care to create January red days, February red days, etc. It's simply, is it a red day? Yes or no. So first let's define that. So I'll say def red days, and let's define the basic criteria of if you're our red day by saying if our close price is less than our open price. Very simple. We'll say if this is the case, then return 1. Otherwise, return 0. So true or false. Now we need to create our same idea as the above, our total method 2 price here. So total method 2 price. And here we're going to say if we do have a red day, if we have here a red day instead of all MCA dates, then we're going to take the close price and we're going to add that to the previous total method 2 price. If we don't have a red day, we're just going to carry the total method price forward. Now we need to repeat the same idea for our count, but this time for method 2. So I'll say def total method 2 count, this time checking if we have a red day. If we do have a red day, then we're going to add 1 to our counter, otherwise simply carry that value forward. And then finally, as you may have guessed, we're going to use the average method 2 price here to calculate that using these two total values that we just created. And that is now going to give us an average price, which we can test by plugging into our same label. Click apply, and we should see this value be different than 362.09. And that goes to 361.23, lines up with the values that we would expect. So now we have method 1, method 2. As you can see, method 2 was way easier since we're simply just looking at red days here. Very straightforward, but it still allows us to add an additional data point to test. Now we need to combine all methods into one set of variables which are all connected to this user input up here. So based on if the user selects default, then we use this method. If the user selects red days, then we want to use method number 2, which is this section that we just created. To do that, we're going to use what's called a switch variable. And the switch variable is going to give us three final variables, that we use as our output. Those variables, so now actually, let's create something that looks like this. I'm going to say switch variables, and I'll make this a little bit bigger so it looks a little cleaner. And now for our switch variables, let's start by first defining the three variables that I think we're going to want to merge into one. The first is going to be which method are you using, so DCA method. The second is going to be based on whichever method you're using, what is your price that you're going to be using. That's going to be the average price. And then it's going to be what is the DCA count, which is the total number of times that we've had to DCA, which will be this total method 2 count or total method 1 count. Now that we have these three variables, let's go ahead and create our switch variable. So we'll say switch. We open parentheses. Inside of this parentheses, we feed in the variable name of this input where the user can select between the two different choices, aka the switch. I'll close out this parentheses, open a curly bracket here, and I'll add in the close curly bracket so I don't forget this. Now inside of our switch variable, we have two different cases. First case is default, second case is red days. Let's list both of them out here first. So I'll say case 1 is default, case 2 is red days. And inside of each of these cases, we will have these three variables defined. So for default, I'll say DCA method is simply going to be equal to 1. And for the second method, that's going to be equal to 2. For our DCA price for method 1, that is going to be equal to total method 1 price, or actually average method 1 price, excuse me. And our DCA price for method 2 is going to be our average method 2 price. Now finally, our last one is DCA count, and that's going to be total method 1 count. If I paste that in, and for method 2, that's going to be DCA count, but this time total method 2 count, and I'll add in the semicolon. Now here we're getting an error which says DCA method is already used because that's the name of what I've selected up here. So let me change this variable name to DCA selected method, and then I can replace each of these two variable names. Okay, now it's time for us to move on to creating our labels. Now I've removed all of our label code right now so we can start writing our code from scratch. Now the first label that we're going to want is the label which tells us which of the two methods we're using. So I'll select yes for when we want to show this label, and for what's inside of this label we might say something like DCA method, and then make the second part of this dynamic. So something like if DCA selected method is equal to 1, then we'll say default else red days, and then let's give this a background of white. Now if I click apply on our charts, we should now see DCA method default. So that would change if we select red days here and I click apply. You can see how that text now changes to show red days. So coming back inside of our code, we have our first label created. Now we need our second label, which is around price. So I'll say average entry. And here we can say, and I'll add a $sign so it's a little neater, as price, and this is going to be DCA price inside. And then we'll output this as a yellow background label. If I click apply, we can now see the entry price, and I'll round this to 2 decimals so this looks a little bit cleaner. There we go. So that looks a little bit nicer. Now we move on to creating in our counter. So I'll say our last one is total DCA. So total number, or total, let's say DCA number. And then here we can simply just output DCA count as our color.yellow. And that should give us 574 for the red days. Let me add in a little bit of a space here. So that looks cleaner. And if I change this from red days to default, we should see the labels update. We can see the total DCA number updates to 120. Now the last thing that I can think of that we need to add is what is the return from the entry price. So let's first define that. So I'll say def current return, and we can put a very simple calculation together here, which is using our current close price minus our DCA price, which ideally is our entry price. Should be lower. If not, then we'll have this number be negative, and we'll divide that by our DCA price. So if we can see what we have here, it takes our current stock price, subtracts that from our entry price, and then divides it from the entry price to give us either the gain or the loss. So we can output that now, add label, yes, and we'll say return, and then plus as percent, and I can say current return, and then let's actually make this color dynamic, where we'll say if current return is greater than 0, then color.light green, else color.pink. And if I click apply and OK, we can now see the return as a percentage. Now if we come back into the code, there's one last thing that I'd like to change, which I'm sure is on most of your minds as well. We started with the first and the last of every single month because I think that was just a lot easier to do. It's easier to run this check. But I think the more default DCA method would be where we invest, say, at the beginning of January and then sometime in the middle of January. Doing so at the beginning and the end of every single month means that our end of January purchase and our beginning of February purchase are essentially back-to-back purchases. That's not what we want with the typical default DCA method. So let's go ahead and fix that. We need to update our entire month methods here for our default to account for this new calculation. Now, instead of replacing Jan end, I'm simply just going to create a new line which helps us identify the middle of January, just in case we ever want to reference the end of the month as well. So we'll leave that. It's not going to be used in the code, but we're going to leave it just in case for the future. Now, to help us identify the middle of January, we can use something like Jan middle and start by saying, hey, are we first off in the month of January? And if we are in the month of January, let's now get the day of the month. And this takes in a parameter of the date, so I'll feed in the get YYYYMMDD function for a default date of the current bar. And we'll say, is this day of the month greater than or equal to 14? If this is true, then 1, else 0. And then if I output this first as a chart bubble, add chart bubble, and then actually instead of yes, let's say Jan middle, close Jan middle color yellow, just so we can see where does this bubble plot true. So when is this entire line true? So if I click apply, we can see that this is true from really, what is this? If I close out, Jan 17th, so the bar after the 14th, since the bar prior to that is the 13th, all the way up until the last day of January, and then we have Feb 1st on this bar. So if I come back into the code, now we can add in one additional test here, which might be something like def jan mid DCA. And that's going to be if jan middle is true, if jan middle is true on the current bar and it wasn't true on the previous bar. That will help us identify just that beginning first candle. Then we'll say then 1, else 0. And if we now output this in our chart bubble, you'll see what I mean. So as soon as I click apply, we should see only this first chart bubble is the one that we actually get to see on our charts. And that's what we're looking for in terms of our entry value. Now we need to create the same concept, so jan middle DCA, but we need to do that for all 11 remaining months. And once we do that, we need to replace the jan end here in our jan DCA to instead be something more like jan mid DCA. So now we're buying at the first of every month and then in the middle of every single month. So that's what's required to update the code. I'm going to go ahead and pause here as I add in these two pieces of code for every single month. So we can go ahead and add in the midpoint value for each month. And then we're also going to update the DCA value. I'll do both of those and then I'll resume the video so we can do a final walkthrough before we conclude this tutorial. Alright, so I've gone ahead and updated the code for all of the remaining months. Let me remove this chart bubble now as well. And I'll show you what I've done. So we had January defined first, where we had the jan middle, the jan mid DCA, and then I replaced inside of our final output, which we use for everything else, I replaced that to start using the jan middle date instead of the jan end date. Then for February, I've done the same thing. You can see that here, and it's using the new February date for the end point, or the second buy point for our DCA, and it's doing that for all of the remaining months as well. Now, given that we've updated all of the DCA code, all of our calculations have automatically updated with this new midpoint. So let's go ahead and see what happens to our SPY calculation right here. This had started with an average entry of 362.10 over 120 different entries. Let's see what we have now using method 1. So I'll click apply. And now we get to see the price update to 362.96, which is a little bit more of an accurate representation if you were to buy using the traditional DCA method. So just like that, we've built our very own DCA calculator. Along the way, you got to experience a bunch of different things as part of this journey. You first learned what method 1 was in a very simple manner using the first and the last of every single month. By the end of this journey, we updated the first and the last to be something more like the first and the middle of every single month, which is a traditional DCA approach, our default value that's connected up here. We also learned how to connect a red days value, where we defined a whole different way of calculating our DCA approach as a pure experimental way. We noticed just how many more DCA attempts we had there. And we also had a chance to compare what the return percentages were, along with what the actual average price was. Hopefully through this journey, you've learned a lot around how to build your own ThinkScript indicator and how to turn Thinkorswim into a very powerful machine that does a lot of the heavy lifting for you. Here we have a DCA calculator which is flexible across a variety of different symbols regardless of whatever you're looking at, along with a variety of different historical time periods, including 5 years, maybe just say 2 years for recent term performance, maybe even something like max available if you want to study all of the data available to you. I hope you found this video helpful. Again, thank you for being a Volatility Box member. We really appreciate your support. The download link for the final version of this indicator is available in the description box below. Take care, everyone. Good luck trading, and I'll see you in our next members-only tutorial.